In this video, I'll demonstrate some of the capabilities of using Databricks to generate sales forecast insights through AI-driven time series modeling and forecasting. I'll show you how to quickly generate synthetic data for testing using open source tools, apply a variety of simple data masking techniques, and finally demonstrate how generative AI can be integrated directly into tabular data using prompts embedded in the code to produce rich, context-aware business insights. So let's get started. Let's start by installing the Faker library, which is essential for generating realistic synthetic data for our sales dataset. Faker is a Python library used for generating highly realistic synthetic data such as customer names, addresses, emails, and more, which is essential for developing, testing, and demonstrating analytics pipelines without exposing real or sensitive data. The code in our first cell installs and initializes Faker, then creates hundreds of fake sales records, ensuring the sample dataset closely mimics real-world logistics sales data structures and variability. This makes it invaluable for prototyping, forecasting models, or sharing analytics examples without risking privacy violations. Next, we'll pick a sample industry and a set of products that we can work with to forecast product sales. For this demo, let's choose the third-party logistics industry with 20 related products. We'll also import the required libraries and define a list of logistics and 3PL products and services. This list will be used to assign meaningful product names to our sample sales records. This next block of code generates a realistic sample sales dataset by simulating monthly transactions for various logistics products over the years 2024 and 25. Using the Faker library, it creates fictional but plausible customer names and addresses to enrich the data. For each product and each month, it randomly assigns a sales date and a sales amount within a set range, ensuring diversity and variability in the dataset. The sales amounts are carefully rounded to the decimal places to mimic real financial figures. Each sales is uniquely identified by a sequential ID. All the generated records are collected into a list, which is then converted into a Spark data frame for easy processing and visualization. The final dataset serves as a rich, structured, and believable foundation for demonstrating data analytics workflows requiring sales data. In the subsequent cell, I wanted to show a simple data masking technique that we can apply to protect sensitive customer information. The customer name and address fields are replaced with the word masked to ensure data privacy and security. This next cell showcases a masking technique applied to sensitive customer data. By hashing the customer name and address fields using the SHA-256 algorithm, the original values are protected while maintaining uniqueness for each record. And for one last example of data privacy and security, this cell demonstrates redaction, a privacy technique where sensitive customer information is completely removed by replacing the customer name and address fields with empty strings. This ensures maximum privacy and compliance when sharing or analyzing the data. Okay, let's get started with the forecasting. This code performs time series forecasting on sales data using the Profit library, an open source tool developed by Facebook. The Profit library excels at capturing trends, seasonal patterns, and holiday effects, making it ideal for business forecasting tasks like sales and financial metrics. Similarly, the AI_forecast function, used primarily in SQL, uses similar principles to predict future values based on historical data, requiring inputs such as forecast horizon, time and value columns, confidence interval width, and model customization options. In this example, Profit builds product-level sales forecasts by preparing data, fitting models with multiplicative seasonality, predicting future-ready daily sales, and combining forecasts to provide comprehensive insights. The code installs Profit, fits the model, generates forecasts, and finally displays the results. This next code compares actual sales for 2024 with predicted sales for 25, allowing for monthly product-level performance analysis. First, it extracts actual 2024 sales from a Spark data frame, converting it to a Pandas data frame for easier handling. The sales dates are parsed into date-time format and split into year and month columns. Actual monthly sales totals for each product in 24 are calculated by grouping and summing sales amounts. Next, it prepares forecasted 2025 data derived from a previous forecasting step, assigns each predicted sale to its respective month and year, and then sums predicted amounts for each product per month to generate monthly forecasts for 2025. The code then merges actual and forecast data sets on product and month, filling any missing values with zeros to maintain consistency. To facilitate comparison, it pivots the merged data, laying out each product with side-by-side monthly actual and forecasted sales for better visual analysis. Finally, the organized pivot table is displayed, presenting a clear matrix of actual versus forecasted sales for each product by month, making it easy to compare performance and trends between years. This comparison provides valuable insights into sales trends and forecast accuracy, enabling businesses to identify growth opportunities, adjust strategies, and make more informed decisions based on both historical performance and future projections. The final code block generates AI-driven insights directly within a Spark data frame containing sales forecast data. It uses the expression function to create a new column called forecast_AI_insight. This column is populated by invoking an AI-generated function, AI_gen, that takes a concatenated string combining product details and sales figures, actual sales amounts, forecasted sales, and the forecast's lower and upper confidence bounds. The prompt instructs the AI to generate short, detailed, and concise insights based on this data. Finally, the enhanced data frame with AI-generated sales and forecast analysis is displayed, providing automated contextual commentary to support deeper understanding of the sales trends and predictions. This framework demonstrates a powerful approach to forecasting by seamlessly integrating synthetic data generation, privacy-preserving techniques, advanced time series modeling, and AI-driven insights within a unified platform. It not only enables accurate, scalable sales predictions, but also enriches those forecasts with automated contextual analysis, empowering businesses to make faster, more informed decisions. By combining data engineering, forecasting, and Gen AI, organizations can unlock deeper understandings of trends to improve operational efficiency and tailor strategies dynamically, delivering significant competitive advantage and measurable business value.